Howdy everybody. I want to see if I can do this in less than 15 minutes. It's going to be tough. This is a biggie, okay guys? I mean, this is huge. Everything we care to know about trigonometry in 15 minutes or less, going to be a tight order, alright? But you can read along with some of the stuff that I might skip, and we got the vocab, you know, the section from the book. We're ready to go. Let's see if we can get this in. Alright, remember the stuff we learned yesterday, a couple days ago, right? We got our 45, 45, 90 triangles and our 30, 60, 90 triangles, and basically what we decided was that no matter what, we were going to have the same ratios among the sides. And the 45, 45, 90s, these sides are going to be equal, and the hypotenuse is equal to the leg times the square root of 2. And the 30, 60, 90, we had the same kind of relationship, but different numbers, right? Short leg times 2 gave us hypotenuse. Short leg times square root of 3 gave us the long leg. And it didn't matter what the numbers were. B could be anything. Could be 0.00001, could be a million. It doesn't matter. This is still going to be twice as much as B. That's going to be square root of 3 times B. It doesn't matter how big. Ratios will always stay the same. That's the basis for trig, guys. All right. Let's look at this 45, 45, 90. And look at this angle Q. It's 45 degrees. We're going to isolate a couple different parts here. Now this is really important. Right angle here. That means this is the hypotenuse. Okay. Hypotenuse is down across from the right angle always. Alright, so that's the first thing we always have to pick up. Which one side is the hypotenuse? Because when we're looking at angle Q, I see one side that we call opposite angle Q, and then we got one side here that is adjacent to it, okay? And the adjacent side is always next to the angle that we're looking at, but isn't the hypotenuse, okay? So when we're talking about angle Q, we're going to go this side is opposite, this side is adjacent, and this side is the hypotenuse, all right? Now, look at the ratios, okay? The ratio of opposite over hypotenuse is always going to be A over A times the square root of 2. Right there, see it? Now, this simplifies down to 1 over the square root of 2, 4.7071. And again, it doesn't matter how big the triangle is. A over 2 is always going to simplify to that value. Doesn't matter what A is, okay? We're going to have the same thing with the ratio of the adjacent side over the hypotenuse. And actually, these numbers work out to be exactly the same. The ratio of opposite over adjacent is always going to be A over A, or 1. All right? Let's look at the 30, 60, 90 just to show you again how this works. I'm looking at angle P, just calling it angle P, and just chose that to be our 60-degree angle. That's pretty random, all right? But anyway, for angle P, here's the opposite side across from it. Here's the hypotenuse, and the adjacent side is, again, next to it, but isn't the hypotenuse, okay? Opposite, adjacent, hypotenuse. So the ratio of the opposite over the hypotenuse is B times the square root of 3 over 2b, which simplifies to 0.8660. The ratio of the adjacent side to the hypotenuse is b over 2b, which simplifies to 1/2, or 0.500. And finally, the ratio of the opposite over the adjacent comes out looking like that. That's what it simplifies to, and it gives us that when we do a decimal on it, okay? Again, no matter how big it is, the ratio of a 60-degree angle, the opposite over hypotenuse will always be that. The adjacent over the hypotenuse will always be that. And the opposite over the adjacent will always be that. Make sense? Hope so, because here we go. We gave those ratios now names, and we called those trigonometric ratios. Okay, because we're going to use them over and over again because they always stay the same for any given angle. So the ratio of the opposite over hypotenuse, somebody gave it the name of a sine. the ratio adjacent over hypotenuse, we call that the cosine, and the opposite over adjacent ratio, we call it the tangent. So looking back at the numbers from the last slide, we can write these things this way. We can call it the sine of p, or we can write it the sine of p. We can also write it the sine of 60 degrees. That number always came out to be 0.8660. Again, going back a slide, there's our 0.8660 for opposite over hypotenuse. Got it? Got it. The cosine can be written like that, cosine of 60, and the cosine of 60 is always going to be 0.5000. And the tangent of 60 can be written like that. It can also be called the tangent of p. That came out to be 1.7321. Now these are only for 60-degree angles, but it doesn't matter if it's 45, 45, 90, 30, 60, 90. It can be any angle, and we will know what that side length ratio has to be, because all triangles with corresponding angles that are similar, corresponding angles makes all triangles similar, therefore all sides have to be proportional. So those numbers will work out differently, but it works for any angle, all right? The ratio of opposite over hypotenuse is the sine, adjacent over hypotenuse is the cosine, opposite over adjacent for any angle is called the tangent. And the best way to remember this, people have been doing this for 100 years, remember it, it is your best friend, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent equals opposite over adjacent. All right, hit that one in the memory banks hard. Okay, so quick little review here, just to give you a work on how this goes. Okay, so the sine of x, well, let's find angle x. The sine is the opposite over the hypotenuse, must be 15 over 17. Good. There are those annotations. What's the tangent of y? Well, y is opposite over adjacent. So for y, the opposite side is 8, the adjacent is the 15. So the tangent of y is 8 over 15. Give the rest of these a try on your own. Pause if you want. Here come answers. Cosine of b, 75 over 125, adjacent over hypotenuse. Sine of c is opposite over hypotenuse. You know what? The sine of c and the cosine of b come out to be the same. Tangent of q should look like that. Cosine of p should look like that. And then we go on. Now, the real beauty in SOHCAHTOA is that it uses sides, angles, this kind of thing together, all right? Where's my slide? Okay. I don't know, I lost a slide. So we use sides and angles together. And again, we can determine the ratio. We've done it for thousands of years, where we've figured out what the ratios are for different angles. Okay, and they always will be the same. Okay, so these can be found on tables or on your calculators. We can figure out what, for example, the cosine of 54 is. Sine of 54, tangent of 54. Okay, again, didn't just have to be 30, 60, 90 triangles or 45, 45, 90s. In fact, let me pull up a calculator here. Let me turn it on. Come on. Clear it off. Here's my sine button on my calculator. If I want to find the sine of 54, that's how I'm going to do it. And then hit enter. And I know the ratio of the opposite over the hypotenuse has got to be 0.8090. Cosine of 54 has got to be the ratio of the adjacent over the hypotenuse, 0.5878. All right? We'll show you how some of this works. And then the tangent, obviously. Tangent of 54 degrees is going to look like 0.1376. All right, continuing on. Here's how it works in a problem like this. If I want to find x and y, I know I've got a right triangle with an angle of 54 and a hypotenuse of 17. I set up my equation Well, the sine of the angle equals opposite over hypotenuse. So here's my 54, here's my opposite, here's my hypotenuse. So there's my equation. The sine of 54 equals y over 17. Now to solve it, I'm going to multiply both sides by the 17. So I get y equals 17 times the sine of 54. All right, go back to my calculator, clear it off again. We can do 17 times sine of 54 and get an answer about 13.75. Good. So y 13.75 by using the sine of 54 equals y over 17 and solving this out. Okay, I'll show you a little bit different way to do it a little later on. Now, we can find x in two ways. We can either use that 54 and use the adjacent over hypotenuse ratio, or the cosine of 54, and multiply by 17 just like we did before. So let's see, cosine of 54 and enter times 17. So x will come out to be about 10. All right. Now, we could do it that way, or we could go back to our old handy little Pythagorean theorem where we could do 17 squared minus 13.75 squared. Enter. Take the square root. Oops. You know where I'm going with this. Take the square root and get our same answer, right about 10. Okay? So, it's all got to work. Hope that makes sense, folks. Here's a few examples for you to do. Pause. Answers coming shortly. Find x. Okay, so the cosine of 21 is x over 10. Here's your math on how to do it. Find x on this one. We're going to use the sine because I have 70. I'm using the opposite over the hypotenuse. As opposed to back here, 21, x was the adjacent over the hypotenuse. Now, these solve out really easily because we can just take the ratio, cosine of 21, off our calculator, and since we have x over 10, here I can just multiply both sides by 10 and get x by itself. Same thing here if we multiply both sides by 31. Be really, really careful though, because sometimes it's not so easy. On this problem, look what happens. We use the tangent of 64 as opposite over adjacent, right? So equals 14 over x. I got a problem here though. My x is on the bottom of a fraction. So I can't just multiply simply like I did here to get that 10 out of there. All right, you with me on that? So we got to do something a little bit trickier on this. Okay, oops, do that. Take this off. Okay, so there's the tangent of 64 from my calculator. Still equals 14 over x. Now here, remember ratios and proportions? That's the way we're going to solve this, okay? We're going to cross multiply to get this, divide by 2.0503, and we get x by itself. Finally, here's our last problem. It's going to use the same kind of thing. You can do it on your own. All right? Hope that works. Now, last thing. Sometimes we need to go backwards to solve these things. Just like we have to undo, an x plus 8 by subtracting 8, or undo an x times 4 by dividing by 4. Sometimes we've got to find an angle by undoing a trig function. We call this an inverse trig function, okay? So if we have two sides and we need to find an angle, we use the inverse function, okay? Again, it just undoes another operation. If we take a square root to undo x squared, that's the kind of thing we're going to do with an inverse sine function. All right, so here the inverse of the sine is called the inverse sine, and it looks like that. Inverse cosine, inverse tangent. Okay, here's how they work. Okay, what's the measure of angle x? So I want to find the angle. I'm given two sides. Because I'm looking at this angle here, and I know the opposite and the hypotenuse, I'm going to take the sine of x equals 8 over 20. I'm going to simplify that 8 over 20. And then on my calculator, I'm going to use the inverse sine, second inverse sine, 0.4000, and that will spit back my angle, okay? So if I know the angle, I use the sine and it gives me the ratio. But if I know the ratio, I use the inverse sine to give me back the angle, okay? We will have a little bit of practice with that. So we use the inverse sine of 0.400 to get the angle back, 23.6. We can try it again over on this problem here. Only this time, here's our angle x. We're looking for the adjacent, and the hypotenuse is the ratio that we know. So we know 6 over 11 equals the cosine of x. Divide that out. Take the inverse cosine of both sides in order to find the angle. Okay? One last problem for you to try. It's a little more complicated one. Pause, give it a thought, follow through. Here we go. Answers coming with a little explanation. And we're done. Hope that helped, and we'll talk to you soon.